Water is used extensively in almost all aspects of fresh-cut produce processing. Water can be used for such things as cooling whole or cut produce before packaging, aiding in removing peels during abrasive peeling operations, washing whole produce to remove surface dirt before cutting, washing produce to remove juices from cut surfaces, conveying produce, rinsing cutting equipment and knives, and sanitation. Wherever water is used during processing of fresh-cut produce, it should be from a safe and sanitary source. This is commonly referred to as being potable. The water used in a fresh-cut processing plant should be documented and verified as being safe and adequate for its intended use, and should meet all local, state, and federal standards for potable water. Municipal water sources can provide safety information and documentation for their water quality. If fresh-cut processors have their own water source, such as a deep water well, it should meet the same requirements. In addition, they should document the safety of their water by routinely performing water analyses. Cold water that is commonly used to rinse and cool produce is often recirculated because of the high energy costs of chilling water. Whenever water recirculation or reuse occurs, whether it is for hydro-cooling whole produce or washing and cooling cut produce, precautions should be taken. Rinse water disinfectant levels should be adequate to prevent the potential for cross-contamination via contamination of the rinse water system. Numerous chemical and physical methods are available to keep water, intended for use with fresh fruits and vegetables, disinfected, such as use of sodium hypochlorite, calcium hypochlorite, chlorine dioxide, chlorine gas, peroxyacetic acid, and ultraviolet light. Special safety precautions are required for certain chemicals, so fresh-cut processors should review and follow the label directions. Processors can consult an agricultural extension agent, chemical suppliers, or food safety consultants for help in deciding what chemicals and physical methods to use. Whatever system is chosen to keep processing water disinfected, it should include the monitoring and maintenance of proper wash water disinfectant levels in the SOPs. Specific steps may include document the functionality of the system, routinely monitor to assure that adequate disinfectant levels are present whenever processing is occurring, and use only food-grade disinfectants that are approved for use on fresh-cut products. Monitoring the disinfectant levels within the wash water and/or cooling system can be accomplished by various means, such as test strips, test kits, or oxidation reduction potential meters, which can be automated to produce real-time continuous monitoring as well as control of disinfectant levels. Be aware that the effectiveness of some disinfectants can be affected by such factors as pH and temperature of the water and the amount of organic matter present in the water. The addition of food-grade processing aids, such as acids to adjust water pH and mechanical screens to remove organic particulate matter, may be necessary to achieve optimal disinfectant performance. Sodium hypochlorite solutions, for example, have an alkaline pH 11 to 13 and will only function effectively if the pH is lowered to a range of 6.5 to 7.5. Chlorine gas, if used as a wash water disinfectant, will lower wash water pH. Calcium hypochlorite pellets dissolve slowly, especially in cold water. Undissolved granules may damage produce as well as fail to maintain the desired chlorination level. For this reason, granules should be dissolved in warm water before being added to cold water. Calcium hypochlorite also raises the pH of wash water above 7.5 if not adjusted. Chlorine dioxide is less affected by pH and has greater oxidizing power than hypochlorite, but it is more difficult to handle as it should be generated on site. Chlorine reacts with organic matter such as soil and vegetable matter. This chemical reaction produces combined chlorine, which is not effective as a disinfectant. Changing the water frequently or filtering organic matter out of recirculated water is recommended to achieve good sanitation. Pre-washing soiled produce, along with monitoring disinfectant levels, will prolong the useful life of chlorinated cooling water. Ozone, acetic acid, or peroxyacetic acid may also be used as a wash water disinfectant, and research is underway to find the best combinations of treatments. Any water contacting fresh-cut produce should be potable, especially when it is recirculated. This is so important that redundant methods may be warranted to assure that equipment is functioning properly and corrective actions have been taken if a system failure does occur. If a human pathogen contaminates a recirculating water system, each piece of produce that subsequently passes through the system will be contaminated. For many produce items that are going to be processed, a pre-wash step is often included in the firm's SOPs. Pre-washing whole produce before cutting helps remove field dirt from items such as melons, carrots, and radishes that have had direct contact with soil. Pre-washing some produce is very effective at removing surface dirt, which may harbor human pathogens. It may not be applicable for produce such as cabbage or lettuce, where outer leaves and cores are removed before cutting. Visibly decayed or rotten produce should be discarded and not used in fresh-cut products. Lastly, water is used extensively to clean and sanitize equipment. Because fresh-cut processing moves at such a quick pace, equipment cleaning and sanitation often occurs in the midst of a processing shift, particularly for equipment that may be used to process various products. If equipment is cleaned during a processing shift, cleaning and sanitation should be done in a restricted area to prevent contamination of already processed produce by cleaning chemicals, sanitizers, or water aerosols. Processors should be aware of and prevent cross-contamination by aerosolized water mists. Food processing requires the use of many industrial chemicals, which when used and stored properly pose little risk. However, if industrial chemicals such as cleaners, sanitizers, pesticides, and lubricants are used or stored improperly, they may contaminate food products. Therefore, processors should only use food-grade chemicals to ensure the highest purity and minimize the dangers associated with inadvertent exposure to the product. Processors should store hazardous chemicals in a locked storage space with access by authorized personnel only, and processors should not leave hazardous chemicals, such as cleaning or sanitizing agents, in the processing area. Packaging materials should be manufactured from food-grade materials, be stored away from any industrial chemicals and other possible contaminants, and not be used to store hazardous chemicals to avoid cross-contamination. Finished products should be labeled or coded in such a way as to allow for the identification of a specific product lot or batch based on raw ingredient supply or production date. Although good labeling and/or lot identification will not prevent the possibility of a foodborne illness outbreak, it may limit the liability if specific batches or lots can be traced to buyers and the product can be recalled. In summary, safe, fresh-cut produce processing requires prevention of contamination by microbial, physical, or chemical hazards during all stages of processing. Controlling the potential sources of contamination during processing will significantly reduce the probability of a foodborne illness being associated with fresh-cut products that are produced and marketed.